This is how to build your first LLM-powered agent using the IBM B framework. So our research labs have been cooking up a React agent framework. It allows you to use a bunch of tools, work with different LLMs, use memory and logging, pretty much everything needed to have a great agent. But it gets better. There's a bunch of features that are going to help you if you're trying to do this for real. I'll come back to these in a sec. I'm going to show you everything you need to know about it in a few minutes. You're probably thinking, why wouldn't I just use LangChain, or can I use open source LLMs, or is it just limited to IBM stuff? It's written in TypeScript and I haven't touched the language since my startup crashed and burned, so this is going to be fun. I'm going to break it down in just 3 simple steps, and it begins with generating an answer using streaming. Now, my code just wants to belong, so I'm going to create a new file called flow.ts to hold it. There are a number of LLM adapters in the B framework, including Grok, LangChain, Ollama, OpenAI, and WhatsonX.ai. I'm going to use the latter. I've already got my API key and project ID. I'll make them available to the process by using the .env.config method. And while I'm at it, I'll bring in the WhatsonX chat LLM class so I can connect an LLM on WhatsonX.ai. Now, rather than using any old model, I can specify the Llama 3.1 70B instruct preset via the from preset class. Here I can also set parameters like the decoding method and the max token. My goal right now is to just generate output using a prompt. To do this, I'm going to use the LLM.stream method. Given I'm coding in TypeScript, I need to import the base message and the role primitive to form a prompt. I can then throw together an asynchronous function and call the LLM stream method. To that, I can pass through my prompt, who is Nicholas Renotte. Just like that time I ate a Carolina Reaper before a 16-hour flight, I've made a catastrophic error. I haven't initialized my project yet or installed any dependencies. Let's fix that. I'll initialize the node project by running yarn init and install tsx.env, the B agent framework, and the IBM generative AI node SDK. I'm going to make one quick tweak to the packages.json file and add a script called flow, which runs the flow.typescript file using TSX. If I run yarn run flow, I get an okay result from the LLM, but it doesn't really know me and it doesn't have access to the net to find out. So I've got the streaming working, but let's be real, you're watching this for agents, and so far I haven't quite delivered. This is all about to change in part 2, building an agent with function calling. Let's change it up. I can bring in the B agent from the framework and begin creating a new instance of the LLM agent. The first parameter I'll pass is my existing LLM. Sometimes you'd rather not know who and what you texted after a big night out, but for our LLM, adding memory is going to provide a lot of context. So I'll import the token memory class and add it to the agent. Now tools. I can bring in the DuckDuckGo search tool to access the net and the Open Meteor tool for all things weather. Again, I'll add these as a new parameter to the LLM. Now to bring it all together. We'll get rid of the function we wrote for the baseline generation and use the agent. There's 2 methods I need to run the agent, run and observe. To the run method, I'll pass the prompt and execution parameters like number of retries. Then I'll use the emitter. This allows me to see what's happening at each stage of the agentic workflow. Each time there's a completed action, I'll be able to see the status by observing the update action. In this case, I'll console log the update key and the update value. This will show things like the output from the function and the final response. And last but not least, I'll console log the final result text for good measure. I can ask when IBM was founded, and after searching the net using DuckDuckGo, we get the correct response. Likewise, if we want the agent to use the weather tool, I can ask what the weather is like in New York, and at the time, get a valid response by leveraging Open Meteor. These tools are slick. We can search a net, call an API, but what if I wanted to write some code or execute some logic using a code interpreter? This brings me to part 3, adding a Python code interpreter. First up, I need to bring the Python tool and the local Python storage class. The Python tool will be used to execute code, and the storage component allows for code to be read and output locally. Now to configure the Python tool. I'm setting up the code interpreter URL and the storage locations. This tells my agent where to run Python code and where to store any files it might create or read. Given we're running our agent in TypeScript, we need somewhere to execute Python code. The B agent framework comes with a standalone code interpreter which can be run via Docker. I haven't done this yet, so let's go do that. The Docker file is available via the B agent GitHub repo. First clone it, cd into it, and install any remaining dependencies. Then I can spin up the container using yarn run infra start code interpreter. Then if I change the prompt to something like is 3 a prime number, I can run it using yarn run flow, and finally we get the correct result. Hey guys, Editing Nick here. I hope you enjoyed the video. Let me know what you thought in the comments, and code will be down below.